Okay, so in number 31, we want to use the double angle identity for sine. The sine of 2 lambda equals 2 sine of lambda cosine of lambda. And we're given that the secant of lambda equals 3, and lambda, the single angle, is between 3 pi over 2 and 2 pi. So that is an angle in quadrant 4. And secant, we know, is the reciprocal of cosine. So the cosine would be the reciprocal of 3, which is 1/3. So the cosine of lambda is 1/3 in quadrant 4. So we know the cosine of lambda, but we don't know the sine. And to find the sine, we're going to need our Pythagorean identity. So sine squared lambda plus cosine squared lambda is equal to 1. That's the Pythagorean identity. Okay, if we substitute in the 1/3 for the cosine of lambda, then sine squared lambda plus 1/3 squared is equal to 1. And that's 1/9 when we square the 1/3. And we're going to subtract 1/9 from both sides. 9 over 9 minus 1 over 9 is 8 over 9. So sine squared lambda is equal to 8 over 9. Then we need to square root both sides to get rid of that squared variable, and that introduces a plus and a minus in our answer. So the sine of lambda is plus or minus. The square root of 8 is 2 root 2, and the square root of 9 is 3. Now, it's not going to be both plus and minus. We need to think about where we are on the circle. And we're told at the beginning that we're in quadrant 4. Sine is negative in quadrant 4. So we're going to be using the negative 2 root 2 over 3 as our sine in this identity. So now that we know the sine and the cosine, we can find the sine of the double angle by taking 2 times the sine of the single angle, which was negative 2 root 2 over 3, times the cosine of the single angle, which was 1/3. So multiplying across the numerator, we get negative 4 root 2, and then 3 times 3 is 9. So we have negative 4 root 2 over 9. And we're going to check that in our calculator. So first we need to figure out what is the angle lambda so that we can evaluate 2 times the sine of 2 times lambda. And we know the cosine of the single angle is 1/3. So let's change our mode to degrees since they're a little bit more intuitive to work with. So we're going to evaluate the arc cosine of 1/3 to find the angle, the principal value in degrees, and that's 70.5-ish degrees. That's not lambda, that's the principal value, that's quadrant 1. Our angle lambda is in quadrant 4. So to get from quadrant 1 to quadrant 4, we take 360 minus that principal value. And we're going to store that as x so that we keep as much accuracy as possible in our variable. Okay, now that we know the lambda, the single angle is 289.47-ish degrees, now we can evaluate the sine of 2 times that angle that we just found, which was x. So we're evaluating the sine of the double angle, and we get negative 0.6285. We're going to compare that result to the decimal answer we found. Negative 4 square root of 2 divided by 9. And we see that our decimals match. And so this answer then checks.